Alright guys, we'll go ahead and get this started. So today we're going to keep on working with different properties of integrals, and today we're going to look at a graph and how we can determine some of the properties of an integral. A key thing when we're looking at a graph, remember the integral is the area underneath the curve. But the key is, like, when we have areas that go above and below the x-axis, that anything below the x-axis is negative. And anything that's above, oh dang it, the x-axis is positive. So we're still going to find the areas to find the integrals, but if we have something that's below the x-axis, like here or this big triangle here, we're going to say that those are negative areas. Oh, hello, Angel. How's it going? Okay. So here we go. So the first question that we have to do today is, okay, what's the integral? Oh, sorry, I'm going to have to slide this over. The integral from 0 to 1 of negative f of x. So I'm going to try to mark on this graph here because we're going to use it a lot. So if I was just going to go from 0 to 1, I'd be trying to find this shaded region, which, okay, that region here, I'm just going to write down here, is... let's see, it's a triangle, so we can do 1/2 base times height. So 1/2, the base is 1, the height is 1. So that is an area of 0.5. But since it's underneath the curve, we'd say that that's a negative 0.5. So all we need to do to find out this answer here is, because if we're finding the integral from 0 to 1 of a negative f of x, so we're going to get the opposite of what we got. So normally if it was 0 to 1 of f of x, we'd say that that would equal a negative 0.5. But since we're trying to find a negative of that, the answer would be a positive 0.5. So the first question is 0.5. Alrighty, next question. I think we got 6 of them to do today, all looking at the same graph. Alright, what is the integral from 3 to 4 of 3 times f of x? Okay, so if we can just find the integral from 3 to 4 of f of x's, we'll just times that answer by 3. So we're just going to look back at our graph. We're going to look from 3 to 4. So that's right here, from 3 to 4. Okay, so that makes a very nice box that's over 1, up 2. So this right here has an area of 2, over 1, up 2. But since we're going to do the integral of 3 of that, we're going to take that normal area of 2 and times it by 3. So we should get 6. Okay. Next, we're going to find the integral from 0 to 7. The integral from 0 to 7 of just regular f of x. So we're not doing anything fancy here, but we're just going to go from 0 to 7. So that's starting all the way over here at this negative, going through these positive values, and then ending right here with some negative. Well, what we can do, remember, any integral we can break up into parts. So from 0 to 7, we can go from 0 to 1, 1 to 3, 3 to 4, 4 to 6, 6 to 7, and just add all those totals up. So we already know this is a negative 0.5. Let's see, over here would also be another negative 0.5. We got this middle part here is 2. Let's find this area of this triangle here. So this triangle has a base of 2, a height of 2, right? Over 2, up 2. Yeah, it just looks a little weird on the scale. So 1/2 of 2 times 2 is 2. That also here is symmetric, so that has an area of 2. So if we want to find the area from 0 to 7, all we need to do is just add up all these totals. We got a negative 0.5, then we got a 2, and another 2, and another 2, and then we end with a negative 0.5. So that's what, 6 minus 1? That should be 5. So from 0 to 7 has a total area of 5. Okay, next we got the integral from 5 to 11. Alright, so kind of the same deal here. We're going to start at 5 and go all the way over to 11. Well, if we look here, we kind of have like a half of a unit. Over one, up one, and we also have another half over here. And then we can count this big triangle piece. This whole big triangle piece, I'm going to ignore this negative 0.5. Let's see, is over 1, 2, 3, 4, down 1, 2. So 4 times 2 is 8. We'll cut that in half. It's a negative 4. So if we want to find the integral from 5 to 11 of regular f of x, we're going to just add up our totals. From 5 to 6, we have a 0.5, a positive 0.5. Then from 6 to 10, it's below the line of an area of 4, so that's a negative 4. And then we end with a positive 0.5. So what's a half minus 4 plus a half? That'd be negative 3. All right. 2 more questions. Here we go. Next is, okay, what's the integral from 0 to 11? 0 to 11, so the whole thing going all the way across. All right, well, let's just make a running total here. So from 0 to 1, we got a negative 0.5. Let's see, from 0 to, let's see, 6. Let's see, we got 2, 2, and 2. And then from 6 to 10, we know that's a negative 4. And then from 10 to 11, we got a 0.5, a positive 0.5. So, okay, let's figure out what that total is. Well, the positive 0.5 cancels out the negative 0.5. That area cancels out that area. We got the negative 4 here, which cancels out those two. So, boom, boom, boom. All we're left with is just 2. 2 would be the area. And last question, what's the area from 4 to 10? Okay. So once again, we're just breaking this up into sections. Integral from 4 to 10 of f of x. It's one of the properties of an integral. You can always break it up. So let's look. From 4 to 6, we have an area of 2. All right, we're going to go to 10. And then we know from 6 to 10 is a negative 4. So that has an answer 2 minus 4 of a negative 2 as a negative 2 area. Okay, so the big goal I want you guys to get from this is when we're looking at a graph, we know that the area underneath the curve represents the integral. What you need to understand is if we have some areas that go underneath the curve, those are negative integrals or negative values. Okay, well, I will post this on YouTube and post it on my story. You guys have a great day. We'll see you tomorrow.